Hi all, how are you all? And it's me Vidya back again, and welcome you all to study with me. So we are into the second lecture of grade 10 physics chapter electric current and circuit, and today we'll be dealing with the topics electric potential and potential difference, and also we'll look into how to draw a circuit diagram and what are the important components of a circuit diagram. Okay. So what is electric potential? So electric potential is defined as the work done in moving a unit positive charge from infinity to that point. Okay, so this is a definition of electric potential. Let us explain how this is happening. So let me consider a point A. Okay, and let us consider some point at infinity. Okay, for example, I am having a charge here at infinity. Okay, I need to bring this charge from infinity to this point A. Okay, I need to bring the charge from infinity to this point A. So what is the work done? Okay, what is the work done in moving in this charge from infinity to this particular point is called as the electric potential at this point. Okay, so we can say that electric potential at A, at this point A, is defined as the work done in moving a charge from infinity to this point A. Okay, so this is what is called as electric potential. Okay, so we studied what is electric potential, right? So it is the work done in moving a unit positive charge from infinity to this point. So this it can be an electron or it can be a proton also. So a unit positive charge, electron or a proton. Okay. Now we are going to study what is potential difference. Okay, so both are different. So electric potential means we are moving a charge from infinity to a particular point, right? But the potential difference means I am considering two different points A and B. Okay, consider the 2 points A and B. So let the potential at this point be VA. Okay, and let the electric potential at this point be VB. So I need to move this charge from VA to VB. So potential difference is what? It can be either VA minus VB or it can be VB minus VA. Depends upon the value. Okay. So potential difference means it is a difference between 2 points. So it's a difference between 2 points A and B on a current carrying conductor. So this is a conductor. Consider this as a conductor and this is a point A and this is a point B on the conductor. Okay, so the work done in moving a charge from a point A to point B is called as the potential difference. Okay, is that clear? So we have two different terms, electric potential and potential difference. Electric potential means it is a work done in moving a charge from infinity to a particular point. Potential difference means work done in moving a charge from a point A to a point B. Okay, and so we can define potential difference as the work done. Okay, work done we represent it as W divided by what is it? Charge. Work done by charge. Okay, so work done by charge is the unit to find out what is the potential difference across a point. So work done will always represent it as joule, right? The SI unit of work done is joule. And what is the SI unit of charge? We have already studied the SI unit of charge is coulomb. So we can say the potential difference is joule per coulomb. Joule per coulomb. Okay. Or this joule per coulomb is also called as volt, because Alexandro Volta is a scientist who discovered this electric potential or potential difference. So potential difference is what? Work done divided by charge, and we know that SI unit of work done is joule and SI unit of charge is coulomb. So joule per coulomb is SI unit of potential difference and joule per coulomb is also called as volt. So this is what? This is the SI unit. This is the SI unit of electric potential or potential difference. Now we studied what is the SI unit of potential difference, and we studied that the SI unit of potential difference is 1 volt, right? The SI unit of potential difference is 1 volt. Now how can we define this 1 volt? Okay, how can we define this 1 volt? That is a question. So we know that the potential difference, we wrote it as it is the work done divided by the charge, right? We wrote the equation as work done divided by charge, and we wrote that the work done, the SI unit of work done is joule and SI unit of charge is coulomb, right? So how can we define 1 volt? Oh, this is what is called as voltage, right? Joule per coulomb is also called as volt. So we can write 1 volt, okay, as the potential difference between 2 points when 1 joule of work is done in moving a charge of 1 coulomb from one point to another. Okay, with this equation we are going to define, give the definition for voltage. It is not necessary that you have to by heart. It is as simple. See, 1 volt is 1 joule by 1 coulomb. So we can write 1 volt is the potential difference between 2 points when 1 joule of work is done in moving a charge of 1 coulomb from one point to another point. Okay, fine. So we have discussed what is 1 volt, we have defined what is 1 voltage, and we know how to find out the potential difference also, that is work done by charge. Now let us solve a small numerical. Okay, the question given is how much energy is given to each coulomb of charge passing through a 6 volt battery. Okay, so what you need to find out is the energy. So what are the given datas here? What are the given datas here? So to each coulomb of charge, so what is the value given? Coulomb Q, charge Q is equal to 1 coulomb passing through a 6 volt battery. So what is the value? V value is given as 6 volt. So this voltage will represent it as V. Okay, so this is a potential difference, will represent it as V, and V value is given as 6 volt. So what you need to find out? You need to find out the energy. So energy means what? It is the work done, right? Energy is the work done. So we know that potential difference is equal to work done divided by charge, right? Potential difference as per this equation, potential difference is work done by charge. So how can we write the equation for work? Work is equal to potential difference into charge. Okay, so if it is in terms of voltage, it can be either potential difference or it can be electric potential. Okay, so work potential difference is given, what is the value? 6 volt. And what is the value of charge given? 1 coulomb. So what is the work done? Work done will be equal to 6 into 1, 6 joules. Okay, so it's a very as simple question. The value given is each coulomb means the value of charge is 1 coulomb, and 6 volt battery, that means they have given the value for potential difference. Okay, you need to find out the energy. So energy and work are same. So we can find out from this equation that work is equal to potential difference into charge. By equating, we will get the value for work done as 6 joules. The next topic is how to measure voltage in a circuit. So we have already discussed about how to measure current in a circuit, right? And we studied about a device called as ammeter, and we know that the ammeter is connected in series with the device, right? So here we are going to study how to measure voltage in a circuit. Okay, as ammeter is like we have an ammeter to measure current in a circuit, we have another one device called as voltmeter. Okay, V-O-L-T-M-E-T-E-R. We have a device called as voltmeter, which is used to measure the voltage in a circuit. Okay, we have a device called as voltmeter in order to measure the voltage present in a circuit. And always keep in mind that voltmeter will be always connected in parallel to the device. Okay, voltmeter will be always connected in parallel to the device for which the potential difference has to be, or the voltage has to be calculated. For example, we have a circuit here and I am connecting a lamp. So across this lamp I need to connect the voltmeter like this. Okay, so I need to connect the voltmeter like this across the lamp parallelly, not in series. This is the lamp. plus minus, we have a current here. Okay, is this clear? So voltmeter is a device which is used to measure the voltage in a circuit. It will be always connected in parallel. So for example, this is a battery circuit, plus minus, a current is flowing through the circuit. This is a lamp, and I am connecting the voltmeter across the lamp in parallel in order to find out the voltage, or in order to find out the potential difference between this point and this point. Okay, if I need to find out the potential difference, for example, let this point be A and let this point be B. If I need to find out the potential difference between these 2 points A and B, I am going to connect the voltmeter in parallel across the device between these 2 points. Always keep in mind, ammeter will be connected in series and voltmeter will be always connected in parallel. So I hope this is clear to you. So we have dealt with what is electric potential, what is potential difference, what is SI unit of potential difference, and we have studied how to measure the potential difference or voltage in a circuit. This electric potential or potential difference will also call it as voltage in a circuit. Okay, so this is for today. We will deal with the next topics in the further classes. And if you like the video, please share this video to your friends, friend circle, so that they may get benefited. And if you really like the video, if you like me to improve a lot, please subscribe to my channel also. Please keep supporting. Thank you all. We'll see you in the next class.